My name is Mrs. Wissen, and I am a 6th grade Horizons teacher at McClelland Elementary. Today, my students and I are working with Mr. Crosslin as we investigate forms of energy through particles.
Hey, thanks for the introduction. So we have been in the past talked about the energy of an object in motion or its position. But today we're going to look at some other forms of energy. And it has to do with not the object, but particles inside the object. And so I'm going to do a series of drawings and maybe some demonstrations, and then I'm going to give you the materials and let you guys come up with some demonstrations. So the first one, find the first box, has to do with something called sound energy. Sound energy is kind of interesting. Sound energy is particles that travel in waves. Now, sound energy, it's kind of like if we take something solid and if we can vibrate it, we can make sound energy. So I remember like in the 3rd grade, we did something with you on the straw oboes, if you remember we did that? Yeah. So I'll show you what I mean. So here is a solid that vibrates. It makes the air vibrate, and the air vibrates through, and then we hear this. That's your ear, by the way. Put an earring in it. And we feel and hear this sound energy, and it sends it to our brain. So sound energy are particles of a solid, of a gas, and back to our ears. Sound can also go through a solid, or it can go through a liquid. Let me show you what I mean. Okay, so here's something that if I get it to vibrate, and you hear that? So that's hearing it through the air. Put your ear down on the table and cover up that other ear. And let's see if I can make this, if you can feel this vibration through the table, okay? Ready? Did you hear it?
Yep.
So you could feel it, so you can hear the vibration, the particles through the air, or you can feel it through the table. That's sound vibration. I was scuba diving in the Red Sea. So I was in water and I wasn't really paying much attention, and I started hearing this loud noise. I thought, that's weird. It sounded like it was really close. And after about the 4th time, I'm underwater looking around. I didn't realize that sound travels really far and fast underwater. And so I came up to the top, and sure enough, about a mile away was a ship that was dropping charges to do sonar tests looking for oil. But it felt like they were right next to me. The sound travels through water, it travels through solid, and it travels through the air. Okay, so the next one we're going to talk about is thermal. There's another word for thermal. What is thermal energy, do you think? Thermal energy, anybody? Heat, right? Thermal is heat, right? Thermal is heat. And there's basically 3 things or so I want you to know about heat. Can I ask you this? Heat, if something is hot, how do those particles travel? Do they keep getting hotter? Do they stay the same? Or do they get cold? For example, let me help you out. If you got a cup of hot chocolate right here, right? And it's hot, you come back in 20 minutes, how's it going to be? Cool. It cools down, right? Heat travels from something hot to cooler. It'd be really weird if you got a hot potato out of the oven, right? You put it on the table and you came back and 5 minutes later it was hotter. You came back in 10 minutes, it's on fire. Yeah. It's a good thing in physics that things don't go that direction. They go from hot to cool. That's one thing. Also, things move through different particles. For example, we're going to try something called, maybe you heard this word before, conduction. Have you heard of conduction? Yes. Conduction is when heat travels through a solid. Okay? For example, here is a block of metal. If I start adding heat to this side with my red If I start adding heat here, where is that heat going to travel? Through conduction, that heat particles will start getting excited and that heat will move down the solid. If I take that heat away, it's going to go in the other direction. Let's do a demonstration of that. These are your particles. Hold those up to the camera. All right, I'm going to start, this is a practice. So I'm going to start vibrating like this. When I vibrate, you can start to feel it. Who feels it the most?
Me.
Yeah. No, he does. And so when I'm doing that, you start to pass one particle down. Pass the particle down. And then CJ, you pass the particle down. But now when I slow down, pass the particles back. I'm cool, I'm cold, I'm cold. And now we're going to start as a solid, just going like this. Here, you're a solid. Look, the particles are just vibrating. Slow. You're a solid, right? And then the heat. Now vibrate them more, vibrate them more, pass them. This is not abuse, this is science. And now I'm slowing down, cold, they come back. You guys get the idea of particles moving? Okay, so this is my solid piece of metal. Strange, I know. Okay, and these are the particles of vibration of a solid. They're just vibrating a little bit. Now I'm going to start heating them up. More energy, more energy. Now the particles are getting really hot, and they're starting to send that energy on down. Oh, that's too much. I better slow it down. And when I slow it down, the particles slow down, and they're back to their regular form, just vibrating a little bit. Very good. Solid conduction. Okay, so that was conduction through a solid. We call it convection, C-O-N, convection, when it is through a gas or a liquid. We call that convection. Now, the best way I can show you that is, what if I draw a pot of hot water, or a pot of water? Now, the reason I do a pot is because, remember, a liquid takes the shape of its container. That's a property of a liquid. So we got some water right here, right? And I'll tell you, those particles, they're just kind of chilling. And they're just kind of moving a little bit. They don't really have any shape. One or two might evaporate out. Everything's kind of just chilling. If you get my meaning, right?
Yeah.
But we start adding heat down here. So we add heat through conduction. Guess what these particles are going to do? They're going to start to vibrate more. They're going to start to move. In fact, they're going to get very energized, and they're going to start to boil, and more of them are going to start coming out and coming out and coming out and changing from a liquid to a gas. And we call that convection. Yeah, would you like to see that with the human model?
Yes.
All right, let's check it out. Okay, so we are water molecules now. So when we get hot, we're going to move in convection currents. And remember, they're cool. So we're liquid particles, just grooving. Oh, dude, excuse me. You know, and so we're moving around. We take the shape of a container. Oh, sorry about that. And, you know, oh, my bad, you know. And so this is cool. We take the shape of the container. But if we turn up the heat, it turns up how we move. All right, let's turn the heat up. Okay. Oh, boom. Sorry. Oh, wow. Really? Oh, you know, in fact, we turn the heat up even more. What's happening? Boom. You know, I'm out of here. I'm a gas. I am out. And come on with me. And now, oh, you know, it gets kind of lonely out here, being a gas. And so we're cool. We're cooling down. And we come back together because we're condensing. And let's go blow it back here and join. Back into the hot pot again. We're moving around again. So those are convection currents. The molecules, the water moves, either through a liquid or through a gas. Cool? Cool?
Cool.
Cool. Okay, so I'm a little tired of my conduction and my convection, but the next one is another type of thermal energy called radiation. Radiation. And this one, well, this one's kind of cool. So radiation is when you start with something like the sun, okay? The sun, and it has particles of energy. Remember, this whole lesson is about particles of energy. And these particles travel through empty space in waves, but they don't heat up the empty space. They don't even heat up the atmosphere. In fact, they only heat up when they strike something like the Earth. So once they strike the Earth, they're moving through space, bam, that's when the energy is released, and they strike the Earth. Would you like to see that as a human model?
Yeah.
I thought you would. All right, let's check it out. Okay, so the last example of thermal heat is called radiation from the sun. Here's my sun. Show us your energy particles. They're going to travel in waves through empty space, 92 million miles, not causing any trouble, through the atmosphere, not causing any trouble, till they strike the Earth. And that's where the energy comes through. Are you guys ready? I hate this part. 1, 2, 3.
Radiation!
Oh, thank you. That was not. I can feel the heat. Go get them. Go ahead. Thank you. Here we go. So, another type of particle energy is nuclear. And there's really two types. So, if I spell this right, N-U-C-L-E-A-R, nuclear, right? And we're going to divide that into two types. One is going to be called fission. These are particles, remember? The other one is going to be called fusion. So we have fission and fusion. These are both a type of nuclear energy. Got that? Okay. And it's pretty simple, really. Let me show you what I mean. Fusion means to fuse, to come together. So if you have a particle like this, for example, a hydrogen particle, which is a plus, and another hydrogen particle, which is a plus, and they're moving, if they crash into each other, if they are moving, which they are, and they crash into each other, we get a tremendous amount of energy released. Fusion. Two things come together, and they usually make something else that comes flying out as a byproduct. In this case, helium, He. So when two hydrogen atoms come together, they don't like to be together because they're positive and positive. Usually positive and negatives like to come together, but if they are going so fast and come together, bam, a lot of energy release and something else is made. Now, fission is a little bit different. Let's say we have something like this. H2, so here's an H and an H and an O. So we have this formula, this molecule, H2O. If we could find a way to split this down the middle, and make these things come apart, fission, we could split them, we would release a whole bunch of energy, particle energy. So fusion is when they come together. Fission is when you tear them apart. Got that? Would you like to see that in a model? Okay,
Yeah.
Let's check it out. Let me show you fusion first. So the sun, if you ever wonder where the energy from the sun comes from, the sun is hydrogen. There's all these hydrogen, and they're flying around. They're both positive charged. They don't want to be together, but there's so many of them, they're so huge, that when they come together, they crash, they release energy, and this is my model. So the energy you see here is the water. So the water is like the energy that comes to the earth. So hydrogen comes together, forms energy, and something else is formed. Helium. So what you see here is a model of two hydrogens coming together, crash, energy is released, and helium is formed. The sun right now, this is happening every second. Billions of hydrogen atoms are coming together, and we see light coming from it. We see energy, a lot of different energy sources come from it. You got it? Fusion. Now, you might have something like this. Here's a molecule that loves to be together. It's sharing everything, everything's cool. All right, stop water, stop. And so this is a happy molecule. Everything's great. We find a way to split it apart, and tremendous force, and when it splits apart, it releases energy. Splitting apart, fission. Coming together, fusion. Splitting apart, fission. The water represents energy. Got it? Good. The next one we're going to talk about, we have two more to talk about, and this one is electrical energy. Electrical, and we use that all the time. Electrical energy, and it has to do with particles. This one's kind of hard to understand also. So I know in fourth grade we made something that looked like this. This was a circuit. Remember we did that?
Yes.
And we put a switch on it. and we came across here and we put a light bulb on it. Switch, light bulb, battery. This is an electric circuit. So if you can visualize this, here are all the little particles that are all aligned here. We'd have to close this switch. When we close the switch, that's open. Now it's closed. Now the particles can go through here. Gives off energy in the form of light and heat. And it keeps going. And that's a drawing. Let's see if we can do that with some models. So this is one of my models. So this represents a circuit. These are the electrons or the particles. So why don't you move that one over there, and you push them on down and keep going. You keep moving them. That one goes over there. Keep going. 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 And so the particles keep moving. Keep moving, particles. The particles keep moving along the path. So
that's
here,
what happens when the battery goes away.
and the battery is disrupted. Thanks.
Battery is here.
Last form of energy, particles, that we need to talk about is something kind of a cool word, I think. Electromagnetic. Electromagnetic. These are particles, electromagnetic energy. These are particles that go in waves. Waves. And it kind of reminds me, maybe you've seen on the Earth, maybe there's an old movie company, RKO, and you see that it has this tower up here. Maybe you've seen this in the movies, the tower, and it's got da-da-da-da-da-da-da-da-da. You ever seen that before? Maybe you've seen where it sends out the waves. Well, radio waves are electromagnetic. Radio waves are. And even up in space, we have satellites that send waves down. In fact, when you use your cell phone, when you're calling on your cell phone, you're sending waves, and sometimes up into space, and they come back on the other, or up to towers. So a microwave is one. Light is one. When you turn on a flashlight and shine it, it's sending either photons or waves out into space. Oh, when you go to the doctor and get an X-ray is electromagnetic. And from the sun, we can get gamma rays and even something called ultraviolet waves. All of these are electromagnetic waves. Like right now, my phone, when I use my phone, those invisible waves go right through the ceiling, right through the walls, up to the tower and back. So this is another form of particles that are moving in waves. Okay? The last type of particle energy I want to talk about is really something that we all need, and it's called chemical energy. And there's chemical bonds. For example, when you eat food, like for example glucose, C6H12O6. This is glucose, a sugar. And when you digest this and it goes into your body, into your cells, this stuff breaks into different things. For example, it breaks into CO2 plus H2O. And when it breaks apart, when these chemical bonds are broken apart, almost like that fission we talked about, when they break apart, they release energy. And so chemical energy is when the bonds are broken and the energy is released. And like right now, I feel warm and I can move and I can talk. So you have sound energy, mechanical energy, and heat energy because of the food that I ate earlier today. The chemical bonds are being released and it's powering my body with energy. And so these are chemical bonds or chemical energy.